Okay people, hello. I'm gonna do a tutorial here, a very simple tutorial explaining how the two things. First, how the rotations work on my GUI, and second, how to compile this on Linux and macOS. I'm gonna first do like the compiling part. This is very simple. While compile it, executables on Linux and Mac aren't like Windows. In what sense? If you compile it to one computer, it's not gonna work for every other, because there are differences in libraries, etc., on kernels. So the best thing you can do is download the source code and compile it yourself. You don't need anything for this, but this is gonna do a couple things. You need to sudo bash ml compiler.sh. You can review the code, it's not gonna install anything weird. What this does is it checks if you have Python. If not, it's gonna install it. It creates a virtual environment, it installs all the dependencies, it installs PI installer, and then it proceeds to, with PI installer, creates the executables, and then it removes the virtual environment. So now you see it's working, processing PI installer. It's gonna create, you can put one file or both files at the same time. It's gonna create executables for both. So in that sense, no problem. Let's wait a little. It takes some time usually, but yeah. See, virtual environment. Why a virtual environment? Because you can't do pip install in every system, in every distro. In some cases there's like a system DE issue, whatever. So to skip that, it's better to run in a BEM, virtual environment. Okay, you already have one. I'm gonna do the hacker one. This should be working. Yes, you already have this. This fully works, by the way. It works for your computer mostly. It's not gonna work for everything, but yeah. Now we open it again, lol. Now you see it created the other executable and removed the virtual environment. You can close this and you have both. Both work, both are ready to use. And no need to install anything. So now you can read from the source code too, by the way. There's no issue. Now let's do like a dataset. Let's go for the HO because it's gonna take less time. Let's do English, just because it's a very easy to model population and a great use as example. So English.HO. Let's do like a normal model, Latvia, Neolithic, Courtware, Neolithic Medea. Let's do Loshburg, Western Hunter-Gatherer. So farmer step, Western Hunter-Gatherer model. Let's do you, Ho, and North. Actually, North.dg. The first strike has to be the most distant from your target. I mean, from target always. Let's do like C del Kino, Hunter-Gatherer, Eastern Hunter-Gatherer, Ponkuklu, Natufian, Epigravetin. So now we have a doubt. Let's say we want to use Zagros. Let's run this first. Zagros / Neolithic / Caucasus Hunter-Gatherers, right? But we don't know which. So we are gonna do fixed sources. This is fixed things are the ones that not doesn't matter what you rotate, they aren't gonna change. So the thing is, let's do like what you rotate is what's gonna change. So this is what's gonna be moved, etc. So let's do Cotias, rotational pool. Let's do Westme and Tepe Abdul Hossein. Let's do a right rotation. This is asking you, out of this, how many do I pick and not do right? I want to do 1. We don't want 2 by guessing, so we're gonna do 1 to 1. How did this run go? This is a good model, but it can be better. It has a slightly higher standard error, largely because we didn't add this. So we're gonna do 1 to 1, and we're gonna rotate. Let's show this. Okay, so now let's see when this is done. Okay, now this ended. So let's see here, what model is the best one? We're gonna do this p-value wise. This is okay. This is good. This is good. Which has the highest p-value? This one. So this is the model we are gonna use. Left rotation, let's do now. This is the same, the exact same, but with the left. So let's say instead of what model with what did win? So you see Tepe Abdul Hossein, Wesme, coaches. The Tepe Abdul Hossein model was the best. So let's do like this. And let's say I don't know which coordinate word to use, because there are many, like we don't know. So let's do coordinate.sg. We're gonna add this to rotational pool. We're gonna add this to rotational pool. Let's do 3, right? So now same thing, run rotation. Did I delete it? Yes. Okay, 3. Let's see. Okay, now this ended, right? So it tested all of them. 75, 57. The standard error. Well, this is very high standard error, so this model isn't good, and also this doesn't make any sense. This is okay, and this is yeah. Oh, I didn't add. I forgot to add Tepe Abdul Hossein, but yeah, you can still see this model is the best one. Why? Because first, even if this has like less standard error, the thing is, what are we trying to do? Step plus Western hunter gatherer plus farmer. This clearly is admixed. Like this coordinate word clearly has like farmer admixture, excess farmer admixture, and I think yeah, it just has excess farmer admixture. So this one is the best one, right? It's really simple, the left rotation, same as the right. Now let's do a different split. Let's do like Latvia coordinate word 2. No, let's not use Latvia coordinate word. Let's say we're gonna do a hunter-gatherer model, like Eastern hunter-gatherer and Iran Neolithic. Well, let's do a default rotation for that. So here what we wanna do is Tepe Abdul Hossein, rotational pool. Let's do like Photias, and let's do like Wethme. So here the thing is, what this is asking us. The default is gonna do, it's gonna move 1 to the left and keep the other 2 as right. This is asking you, out of the rotational pool, how many do I move to the left? So here it's gonna be 1 to 1. We just want to move 1. So yeah, let's just run rotation. Let's clear this. Bam, rotation analysis. It's gonna do 3 models. Yep. Okay, now the rotation is done. So let's see. This model has horrendous standard errors. Oh wait, I'm retarded. Okay, I realized I didn't add A&E as right for this, for Eastern hunter gatherer. So let's see. These models, they're all gonna be good, I think. Yes, but except this one. So let's see what model is the best one here. How we rank p-value. So the p-value here, it's a pass, but it's low. Here it's really solid, and here it's bad, you know. So this is the best model. This is the model we might take. But now let's say I want to try more things. I want to do like Tepe Abdul Hossein, and I want to do also Sat Surblia, which is also Caucasus hunter-gatherer. Now we would face an issue that If we move 1 to the left, we have 4 populations left. No, wait, 1, 2, 3. We have 3 populations left. That's a lot. This is a little worse than 2. Like, see, now we're gonna have 4 populations left. That's a lot, and it's gonna mess up the model. So what you can do is, let's go to this, remove from right. I move 1 to the left. Okay, I have 4 left. You can remove them. Like, you can do like, if you have 4, let's remove 3 to 3. So it's gonna move 1, keep 1, remove 3. Now let's do like the models. It's gonna do 20 models, that's a lot, but let's see. Okay, now, so this ended, right? Now, there are too many, so we're gonna do something that I have. Let's do parse. Let's go to model ranker, parse. Let's put desktop, and let's put ranker models 1. Boom, done. So now what is this? This ranks the model based on the p-value. If it's between 0.01 and 0.05, it's yellow. If it's between 0.05 and anything above that, it's green. And if it's below 0.01, it's red. Or has like something that doesn't make it a pass. But here, what model is the best? This one. All is good, everything's good here. So let's see. It has Satsurbia, Leto-Paleolithic, and Tepe-Abdol-Hussein. That's it, that's the best model we had. But now let's say I want to split CSG and Iraniolithic. How can we do that at the same time? You can enable the group constraints. So let's remove this. I had many, but what this does is, you need the populations that are here. That are here, they need to be here, or rotational pool. So here, let's say you want to rotate each of these groups independently. You can do that with like 5 groups, 10 groups. Why? Because it's gonna increase the possible models exponentially. So you're gonna have 1,000,000 models. So here you have one, like we have 2 populations, the 2 causes control gatherers. We want to move one as left, keep the other one. Like this is good. Here we have 3 populations that are Iraniolithic. We want to, let's say, move 1, and we can either keep the 2 or remove 1, which is what we're gonna do. You can enable, disable, whatever, but for this one, that like that. And here, since we are dealing with 2, let's do like this. What happens with all these other options? Real simple. This will affect populations that aren't on the group constraints. So if there is any population that isn't here, that like is part of this but not part of this, it's gonna work with those. The same with this. You can, let's say we had this group and we had like 2 other random things. You can do like 3 to 3, and it's gonna move the one from the group, another one from the other group, and another one from here. But let's keep 2 to 2, and let's run rotation. Let's clear this. So let's see how many models should this be. 12. Okay, let's see. Okay, this has ended right now. So let's do the same. Let's do parse 2. Let's go by model ranker, parts 2.csv, ranked models 2. Bang! Done. Let's close this. And you have, no, not this. Okay, so what models were good here? The other ones didn't pass because of bad confidence/C. So here the most that passed was the one with Satsorbia, Leto-Paleolithic, and Luristan, anchored with Cotias and Westme. It had a p-value of 0.5, which is very good. Model 11 was. So it was this one. Yeah, this one. This model. This is a good model now I think about it. But okay, so now what we can do with these models, you can do like let's say we want the best one. Okay, let's do this. You can parse model 1 txt, no, not csv for this. You can go here and like make a chart for the model. You can put your Discord username. You can do many things. You can customize the color, you know. You can make it on bars and pie chart. You can put it dark. Different chart formats, you know, for one to see. Like here. Here it rounded it up. These are all the formats and things you can do. There are alternatives. You can pick the one you like the most. And yeah, that's it. Oh, something I forgot to explain. Nearly forgot. How do these two work? Let's say we're doing a normal rotation, or you can do it with these two. You don't want Luristan as a left. Like you want it as a right, but not as a left. You can restrict it from left. So any model that would have Luristan as a left is skipped. It's not gonna be done here. And same with this, but with the right. Like, oh wait. Any model from here that has Luristan as a right is gonna be skipped. So you're gonna have it always as a left, never as a right. But yeah, this is how everything works here. This is probably the most complicated thing, but it's really useful in some situations. But yeah, that's it. And I'm not gonna explain left, right, right, left, because they are basically, I don't even know why I've implemented this. And yeah, that's it, yeah.